We are studying a new topic, and that is power. To understand the power, let's understand the energy. What is energy? Energy is ability to do work, right? Now, the ability to do work not going to help you understand energy really, because that doesn't address what is going on behind the scene. So, what is the definition we're going to use? We're going to use this definition very carefully. Okay. Force causes displacement. That's the definition we're going to use. Force causes displacement. Even we're going to have to redefine this force causes displacement thing. Okay. Speaking of displacement, let's say I want to displace this Einstein bust for 1 meter to the left, my left. Okay. So to do that, I have to do what? I have to apply force, and force causes the displacement. But is the force causing displacement? No. Did I apply force? Yes. But why did the force not cause displacement? Is because the force didn't act at the direction of the displacement. Okay. Now, that's the. Now we're gonna kind of like change our definition. So what is energy? Energy or work, the definition of energy and work is when the force acts at the direction of the displacement that causes the motion. Okay. All right. Now I'm going to do scenario 1 and scenario 2. This is scenario 1. This is scenario 2. What are the differences between scenario 1 and scenario 2? Scenario 1, did I apply force? Yes. Did I apply force at the direction of the displacement? Yes. Did I transfer energy? Yes. Did I do any work? Yes. Did the force cause displacement? Yes. Okay. Scenario 2, did I apply force? Yes. Did I apply force at the direction of the displacement? Yes. Did I transfer energy? Yes. Did I do any work? Yes. Did the force causes all the displacement? Yes. So then it seems like there are no differences between scenario 1 and scenario 2. Let me show you scenario 1, scenario 2 again. Scenario 1, scenario 2. Okay. So how can you distinguish the differences between scenario 1 and scenario 2? Well, here's how. We're going to ask a few questions. Scenario 1 and scenario 2. Which scenario we did more work? Well, we did same amount of work for both scenarios. Which scenario we spend more kinetic energy? Well, we spend same kinetic energy behind the scene for both scenarios. Then how can we ever be able to make a distinction between scenario 1 and scenario 2? Well, the new concept, and that is power, right? And the power really important concept is because what is science today? Today's science is tomorrow's technology. When Sir Isaac Newton observed an apple fall, that was, and he discovered F equal ma, he really wrote it and he published it, Principia 1685, he observed apple fall 1666. That was the birth of science, right? And that is science. And their science led to technology. About 100 years later, about 80 years later, 1656, another boy in the same country observed something that really inspired him to invent machine using F equal ma. Who was that boy? As the story goes, one day his mom was trying to make tea and she forgot, she left home, and the boy left alone in the home, and the boy was all of a sudden something caught his attention, and there was a kettle on the stove, and the water was burning, the temperature was increasing, and he saw that the lid, lid of the kettle moving up. That's really amazing, because he thought that everything you have to do it by hand. Okay, everything around us, people do it by hand, and there is no way you can do something like not using hand. And he saw there is no involvement of hand, human hand, something causing something moving up, steam causing lid of kettle moving up. That's really amazed him, right? So he increases the temperature, and he saw what happened if you increase the temperature. He ended up burning home, but that's not important. What important is that really inspired him to create the fast human machine in 1776. So we often say 1776, England lost something and gained something. England lost America in 1776, and England gained something, and that was machine. Was the magnitude of gain bigger than loss? Yeah, of course, because the steam engine made England superpower within few years. In terms of economics, in terms of military power, and England ended up ruling almost the entire world for many years. From 1776 to 1945, England was the only superpower because of F equal ma, the science, to P equal W over T, the machine. Sir Isaac Newton to James Watt. The boy name was James Watt. Okay, let's talk about James Watt and his discovery. I've divided in two types: instantaneous power and average power. And what is the connection between F equal ma and power? Okay, the connection is very simple. So instantaneous power is W over T, which is Fd over T, which is MAD over T, which is MAV, and this is instantaneous power. What is average power? Okay, it's the same thing. W over T is equal to Fd over T is equal to MAD over T is equal to MAV. In this case, velocity is average, and average velocity is V initial plus V final over 2. Okay, now I'm going to give you one example, and that will hopefully help you understand what's going on. Okay, now let's say you kick a soccer ball, right? With what degree? Soccer ball is 2 kilograms, and gravity you're going to use negative 10, of course. Acceleration due to gravity you're going to use negative 10, so I don't have to use calculator. This is dy, this is t. Okay, so you're going to kick a soccer ball with 20 meters per second at 16 degree, 37 degree. Okay, so we're going to convert this one to VT graph. The velocity is 0 over here. Okay, and then we're going to convert this one to acceleration versus time graph. And acceleration, since it is free fall, well, you throw the ball in the air, acceleration can be nothing but negative 10. Okay, so what is this one over here? Okay, let's find this. Velocity has Vx and Vy. So 20 cosine 37, 16, 20 sine 37, which is, no, this is 16, yeah, this is 12. But check, I wanted to check. So this must be 12 and this must be negative 12. So the equation for this one is d is equal to VIT plus half AT squared. So this must be 12t minus 5t squared. That's the equation. Equation for this one is VF is equal to VI plus AT. VF is equal to VI is 12 minus 10t. And the equation for this one is, you can write it as in terms of is a function of t. AT is equal to 10, negative 10 rather. The things we are trying to find is here. We are at location, so we're going to call location 1, 2, 3, and 4. This is location 1, this is 2, this is 3, this is 4, and this is 5. At location 1, and then 2, and then 3, and then 4, and then 5. Of course, the time at location 5 is the thing we are trying to find. What is the time at location 5? Okay, VF is equal to VI plus AT. VF is equal to negative 12, VI is equal to 12 minus 10t. So t is equal to 2.4. So this is 2.4. If this is 2.4, this must be 1.2. If this is 1.2, this must be 0.6. and then this must be 1.8, and this must be 0. Now velocity. The velocity is velocity. We have a velocity function over here, and we can bring it over here if we want, right? And velocity at 0 second, at velocity at 0 is 12. If you plug 0, you will get 12. That's good. Velocity, of course, at y direction, and velocity is 0.6, 0.6. So that's 12 minus 6, so it's 6. And then we know this one, and that must be minus 6, that must be minus 12. What is our acceleration? Acceleration is negative 10 everywhere, right? Okay, very nice. After acceleration, what are we going to find? Kinetic energy. Kinetic energy is half mv squared, right? So half m is 2, v is 12 squared. So that gives you 144. And this one is 60 squared, and that gives you 36. And that gives you 0, that 36, that 144. And now we're going to find the power, instantaneous power. This one is instantaneous. So the power is MAV. So M is 2, A is of course negative 10, and V is of course 12. So 240. Okay, this one is negative 240. This is 2, acceleration is negative 10, and velocity is of course 6. So this is negative 120, negative 120. This is 0, this is 120, this is 240. Okay, now what is the net power? How can we find the net power? Power net is equal to sum of all the power. Power at location 1 plus power at location 2 plus power at location 3 plus power at location 4 plus power at location 5, which is 0 watt. Okay, now remember the net force of instantaneous power is of course 0 watt. Now you're going to see the net power of the average power. So let's find the average power. Average power between 0 to 0.6 second watt. We're going to say MA delta V. Delta V is VI plus VF over 2. Okay, so what is VI? Well, we have a velocity equation. V of t is equal to VI plus AT. Okay, when the time is 0, and then the velocity is, VI is of course, I erase it, 12 minus 10t. So this should be 12 minus 10t. So when this is 0, this is just 12. So this one is just 12 plus. When this is 1, let's put 1.2. 1.2. So when this is 1.2, then the 12 minus 1.2 times 12 minus 12. So this is 0. So average velocity is 6. Average velocity is 6 from here to here. Average velocity. So average velocity from 1.2 to 2.4. Okay, so V of t is equal to 12 minus 10t. So V of 1.2 is equal to 0. And V of 2.4 is equal to 12 minus 24. So negative 12. Okay. So Vi is 0. Negative 24 divided by 2. So it's negative 12. Okay. So the power is MAV. So M is 2, A is negative 10, and V is, let's see, what is V? V is 6. So the power of 0 to 1.2 is negative 120. Okay, so from here to here, power is negative 121. Now from average power. So from here to here, the power, average power is from 1.2 to 2.4. Average power is MAV. Okay, so M is 2, A is negative 10, and V is negative 12. Okay, negative 12, I don't know. Let's see, I don't know. Okay. V of t is equal to 12 minus 10t. So V of 1.2 is 0. and V of 2.4 is negative 12. Negative 12 and negative 24. So this is 24, so negative 12. So 0 minus 12 divided by 2, so negative 6. All right, so negative 6, so negative 100, positive 120. So P of 2 is positive 120 watts. So what is the network? The network is P1 plus P2, which is 0. All right. So no matter what way you do, instantaneous or average, the network is 0. Find the net power differently. We're going to use the kinetic energy to find the net power, and again the net power going to be up to 0. And this time we're going to also not only use the only the dyt or vyt, but also vxy. Okay, so again, Messi kicks the soccer ball. Okay, Messi kicks the soccer ball with 37 degree at 20 meter per second, and this is dxy, and this is t. Okay, so what we are trying to find is I'm going to give you 3 vector. Vector 1, we're going to say vector 1 is t equal to 0, and this is vector 1. And we're going to say this is vector 2, t is equal to 1.2, and this is vector 2. And we're going to say this is vector 3, t is equal to 2.4, and this is vector 3. Okay, what are you noticing about this vector? First, we're going to have to write the name. So this is vxy, this is vx, this is also vxy. Notice that over here you have vx and vy. Vx is 16 and Vy is 12. Over here, Vx is 16 and Vy is 0. Over here, Vx is 16 and Vy is negative 12. So what is Vxy? 16 is square plus 12 is square. So Vxy is equal to 20. What is Vxy? I don't know. You can write Vxy. 16 is square plus 0 square. 256. And this is also going to be xy is 20, because if this is 20, this one has to be 20. So this is 20, this is 16, this is 20. So what is kinetic energy over here? Kinetic energy over here is half mv squared. So mass is 2. Here use the same mass. So half 2 20 squared. So this is 400. Kinetic energy over here, therefore, is 256. Kinetic energy over here, therefore, 400. Okay, so what do we want to find? Power. Power at where? Between the time 0 and time 1.2. Okay, to do that, you're going to write power is equal to delta Ke over T. Power is equal to half mv final square minus half mv initial square. So this is v final, this is v final, okay, and this is v initial. So okay, so then if this is v final, then this is 256 and this is 400. So T is 1.2, so power is negative 120 from 0 to 1.2. And from the other one is okay, so the power is equal to half mv final square minus half mv initial square. V final would be 400 of T. So 400 minus 256 divided by 2.4 minus 1.2. So this one gonna give you a positive 120. watt. So P1 plus P2, negative 120, positive 120. So again, power is 0. We use the net power. So this is net power. Power net is equal to 0. That confirms our hypothesis that the net power is 0 no matter which way